a very good day. So, our group will be presenting data linearization. So, these are our teammates. Our teammates consist of the first person is Lim Junjie, second is Joseph Lin Weijie, the third one is Lo Zhaotian, fourth is Xiao Chihyong, fifth is Octavia Odella, sixth is Kevin Raman, and seventh is JCJ. So, let's say there's a set of data. It's going to be fit a power function in the form of y equals to c exponential power of dx. So where the c and the d are the constants. This equation can be linearized by taking logarithm on both sides. So what we do is actually ln the both sides and then bringing down the dx into this form. And then so this form will be realized. And then by defining a new variable y equals to ln y and x equals to x, we can use the linear list equation with the relation y equals to a plus bx, whereas the a is ln c and b is d. Hence, we can obtain ln y equals to ln c plus dx, where the ln y is the y, ln c is the a, and d is the bx. So lastly is the variable transformation. And in this slide, we'll be providing the table that shows that some non-linear relation and transformation that can be used for linearization. So these are the form of non-linear relation and transformation that can be used for the linearization. And these are the equations that will be provided in our equations sheet.
Hello everyone, I'm going to present data linearization from chapter 3, interpolation of the curve fitting. And I'm going to show you an example to make you understand more about this topic. And from the lecture slides, I got the example 17. And given the following data, which is this table, the curve y equal to c exponential dx, where c and d are constant, can be linearized to the form y equal to a plus bx by linearization process. By using least square linearization process, determine the value of c and d in such that the data given can be fit to the curve. Okay, so now start by copying down the table from the questions. And from the introduction, we know that y equal to c exponential dx can be equal to ln y equal to ln c plus dx. And this equation, the ln also can be seen by big Y equal to ln y and a equal to ln c and b equal to d. Okay, so by linearization, we plot a table to solve the questions. Okay, so we start with the x1, y1, and ln y1 x squared and x1 times y1. Okay, so we start with 0, right? X equal to 0.0 and y equal to 1.52. Okay, so we use our calculator to calculate the value of the y1, big y1, which is ln small y1, is equal to 0.4187, and the x1 square, we just square the x1 from the table obtained, and x1 times y1, which 0 times 1.52 is equal to 0. Okay, so we keep doing by following number, which is 0.2, 0.4, 0.6, 0.8, and 1.0 0. Okay. I'll show you the full table of the solutions. Okay, so after using calculator to obtain of this value, you should get the same value as mine. Okay, and the total of x1 is 3, and y1 is not important, so not. And the ln y1, the total up value will be 3.9794, and x squared total out value will be 2.2, and the x1 times y1, the total up all the 6 value will be the 2.3317. Okay, so we proceed that look back to our questions. There's a hint that the matrix equation is given, so we have to apply into our solution. Okay, sorry. Okay, so here it is. We make it into an equation from the matrix equation from the questions, and it can be written in this way. The n summation I equals 0, 1 is equal to the n value from which is how many set of value we have, which is 6. Okay, is 6. So we just sub the value inside the matrix equation, and the first one will be 6. Okay, n summation I equal to 0, 1 is 6, and n summation I equal to 0 x1 it will be 3, which is we obtained through the table we have plotted just now. Okay, so n summation I 0 x1 is 3, and n summation I 0 x squared will be 2.2, which is shown here. Okay, so a and b we copy, and n summation I equals 0 y1, we take a value from the total value. Okay, and same with x1 times y1, okay, 2.3317. Okay, just by subtracting the value, and now we got 3 ways to solve the equation. We have the simultaneous, Cramer rule, and the inverse matrix. And because this is just 2 equations from this from here, so we just use the simultaneous, which is more easier way to solve it. Okay, so we form the equation 1 and 2 by simultaneous, and then from calculator we obtain the value a equals to 0.4189 and b equals to 0.4886. Okay, so since we have the value of a and b, so now we look back into our this linear equation, which is y equal to here, which is a equal to ln c. Okay, a equal to ln c. So we have the value of a, and we can find c, which is 1.5203, and d is equal to b, so you just take it directly, 0.4886, and then we can Okay, so now we have finished our task by finding D and C, and then the final step will be putting the value of D and C into the equation, which is y equal to 1.5203 exponential 0.4886x. And because it's data linearization, so our graph obtained will be a straight line, because look back into the equation, y equal to a plus bx, because only the x-axis only sorry, the x before with the gradient with is only above 1, so it should be a straight line. And here's the graph. Then you can see a great straight line with best fit. Okay, so hopefully you all understand the example I've shown here, and thank you very much for listening.
Good day everyone. So now let's see about the example 18. So this is the question of example 18. So we are given that VTA equal to B. So the first step is to transform two power equation in the form of y equal to alpha s power beta. So we can transform this equation into this equation first, and then by adding log at the both side of the equation we'll get this equation. And then by applying the law of our logarithm, we can get this equation. So by observing this equation and this equation, we can know that v is actually equal to y and t is actually equal to s. So since we know that v is actually equal to y, t is actually equal to s, and don't forget that our number of data is actually equal to 5, so we put v and t into y and s, and then we just press the calculator, we are then get log s log y square of the log si and result of log si times log yi. So here we can then get s min and y min. So s min is actually dividing the value of sum of the log si with the number of data, which is 5, and then you will get this value. And then y min is actually you just divide the sum of the log yi with the number of data, which is 5. We will then get this value lah. So from previous slide, we know that since log v equal to log b minus a log t, and y min is actually equal to a s min plus b, so we can then make the assumption that log b is actually equal to y min, log b is actually equal to big B, and log t is actually equal to a s min. So we know that, of course lah, so big A is actually equal to small a lah. So we make the difference of alphabet is to let us to calculate our value more easier. So we can then find a by using this equation lah. So you will then see that the sum of the SIYI is actually equal to sum of the log SIY times log YI, and sum of the SI is actually equal to 3.1295, and sum of the YI is actually equal to 11.4831. And do notice about here, this is the sum of the SI square. So actually it's this value, and this is the square of the sum of the SI, which is this value lah. So 3.1295, 3.1295. So since we know that y min is actually equal to as min plus b, we then can get big B is actually equal to this. So by equating log b here, log b is actually equal to big B. So by applying the law of logarithm, we will get small b equal to this value lah. So again, big A equal to small a, so automatically big A equal to small a, so which is equal to this value lah. So this value. So we just put our both of the value of a and b into this equation, y min equal to as min plus b, we will get this equation. So another equation is log v equal to log b minus a log t. So again, we put the respective value into the correct place, and then we will get this value lah. Of course, by in order to get this value, you must apply the law of logarithm at this part lah. So this is basically how method 1 works. So let us see method 2. So method 2 is actually by solving the simultaneous equation. So we are basically form these two equations lah. So where 3.1295 is actually equal to sum of the log Si, number of 5 is actually equal to log number of data, and this value is actually equal to sum of the log Yi lah. So in order to get the second equation, we actually get this value 2.1375 by using this sum of the square of log Si, and this 3.1295 is this sum of the log Si, and this value is actually sum of the log Si times log Yi lah. So and then by pressing the calculator, you will get A equal to this and B equal to this. So again, since log V equal to log B minus A log T and Y mean equal to AS mean plus B, we can let again log V equal to Y mean, log B equal to big B, log T equal to AS mean, and big A equal to small a. So again, we sub both of these value into the respective value of A and B, we will get this equation, and then again we sub the corresponding value into this logarithm equation, we will then get this value. Of course, at here again you need to apply the law of logarithm. So let us see about the least squares fit of power model to the data. So this is basically the graph of log Y equal to A log X plus B. So this is basically the shape of the graph lah. And then let us see about the power equation fit along the data. And this is basically the shape of the equation of V equal to 309.8791 times T power of negative 0.3109. So this is the shape of graph lah.